We've been using this analogy between algebraic expressions involving variables like x squared plus y plus 21 and well-formed formulas like p and not q implies r. And just as x squared plus y plus 21 doesn't have a numerical value until you substitute in some numbers for x and y and then combine them using plus and multiply, a well-formed formula doesn't have a truth value until you decide on truth values for the propositional variables and then combine those truth values using the connectives in the well-formed formula. But while we all know how to do addition and multiplication to combine a bunch of numbers into a single number, we don't yet know how we're going to combine logical values using our connectives, and that is the subject of this video. So let's suppose that we have a truth assignment for a set of propositional variables. And what we'd like to do is to extend that truth assignment so that we get truth values not just for those variables, but for any well-formed formula using those variables. And the way we do that is as follows. We think about the structure of a well-formed formula. A well-formed formula has two possibilities. Either it's the simplest possible well-formed formula, so it is a propositional variable, or it's built from one or two simpler well-formed formulas using a connective. Now, in the case where the well-formed formula is a propositional variable, the truth assignment already gives it a truth value. In the second case, what we're going to do is insist that the truth value of, for example, phi and psi is going to be the truth value for phi and the truth value for psi combined using and as a logical operator. So for example, if phi became false and psi became true under our truth assignment, then the well-formed formula phi and psi will get the truth value false and true, which, as you can see in the table down here, is going to be false. So this way we can work our way down from more complex well-formed formulas to simpler ones until we reach the very simplest well-formed formulas, which are propositional variables, and then our truth assignment will give us truth values for those propositional variables. So this is equivalent to just substituting in truth values for the propositional variables in your well-formed formula and then combining them using the rules given by the truth tables for connectives. So let's take a look at an example of doing this. We have some propositional variables p and q, and we've got a truth assignment v such that v of p is true and v of q is false. And the first well-formed formula I'm going to be interested in giving a truth value to is this one here, p implies q. So the way that we can work this out is to go down to the propositional variables here and substitute for their values. So here p was true and q was false, so this one becomes true implies false. Now if we want to know the value for this, we've got to look at the truth table for implies, which I've helpfully written out for you over there, and you can see that the correct row, the row we need to look at, is the one where the first thing is true and the second thing is false. So that's this row here, and you can see that in that case the whole formula is going to become false. Okay, let's try another one. So we'll look at the well-formed formula q implies p, and we'll try and get the truth value of that under the same truth assignment. So again, we substitute in for p and q, and we get false implies true. So we go away and look at the truth table, and we look at the row where the first thing was false and the second thing was true. So here we are, we're on this third row of the truth table. You can see that the correct truth value there is true. So that well-formed formula q implies p becomes true under this truth assignment. So let's now look at this more complicated example right at the bottom here. So we have a well-formed formula which is p implies q and q implies p. So we can work this out just by substituting in for p and q here, and you'll get some complicated expression. But actually what you might notice is that we've done two of the parts of this formula already. So the formula comes in two parts. There's a p implies q and a q implies p. And we already know the truth values for those. So we know that the p implies q part will be false because we worked that out as our first example. Then I have to combine that with and, with the truth value for q implies p, which again we already worked out, that was true. So what we've got is false and true. And of course, the answer to false and true can be found by looking at the false true row of the truth table for AND over here. So actually, we've already highlighted this one. False and true is false. So the answer here is false. Okay, so that's it. That's how we find truth values for any well-formed formula once we have a truth value for the propositional variables. So let's move on and look at some slightly more complicated examples. We are going to take, again, the same two propositional variables P and Q, and we're going to take the same truth assignment. So our truth assignment makes P true and it makes Q false. And we're going to have, well, we're going to begin with this well-formed formula phi. So phi is P and Q, or not P and not Q. And the question is, what is the truth value of phi under this truth assignment? So again, we could, if we wanted, just plug everything in, so substitute for P and Q and work out the whole thing. But because this is quite complicated, it might be simpler to work out the parts of phi one at a time. So we could begin with working out what is the truth value of P and Q under this truth assignment. So P is true, Q is false, so this is true and false, which we know is false. Okay, let's do another. So the other part, well, there are some other parts. So we have V of not P. That is not V of P. P was equal to true, so this is not true, which is false. Let's do another. So not Q, V of not Q. Well, that would be not false, which is true. So we can do the next one, though another part of this is not P and not Q. So excuse me for missing out some brackets here, not P and not Q. Well, you know that not P was false, and you know that not Q was true, so we've got false and Q and true, which is false. Okay, so we're finally ready to go. We've worked out the two outermost parts of phi. We know that P and Q is false under this truth assignment, and not P and not Q is false under this truth assignment. So what we finally got for the whole thing is that V of phi is, well, P and Q became false, and not P and not Q became false. So the result is false or false, which is false. Okay, so under this truth assignment, phi was false. Let's try another example now at the bottom here. So our new well-formed formula is called psi. And psi is the well-formed formula P implies, in brackets, P implies P. So we'll stick with the same truth assignment where P is true and work out the truth value of psi under this truth assignment. So let's look at again, we could just substitute in directly and look at what is true implies true, or we could work out one part at a time. So V of P implies P, that is true implies true, which is true. So V of P implies P implies P is true implies true, which again, looking at the true row of the truth table for implies, is true. Okay, so this well-formed formula, psi, was true under our truth assignment. And one interesting thing about psi is that if you let another truth assignment, W, be defined by W of P is equal to false, then you can check, and you should check, that actually the truth value that W gives to psi is also true. So psi was a well-formed formula with just one propositional variable. So there are two possible truth assignments. Either that variable is true or it's false. Only two possibilities. And actually what we've seen is that under either of those possibilities, psi gets the truth value of true. So it was true here, and it was true there as well under the other truth assignment. Well-formed formulas with this property that they are true under every possible truth assignment for their variables are called tautologies.